Hello, my name's Chris Kurzik, and I'm from Athabasca Engineering Solutions, my own company. And why I'm here today is to talk about product types at the request of a long-term friend of mine and alumni member, Ika Guacha, from the Department of Mechanical Engineering. And I'm here to talk about the UNS and how it relates to ASME boiler pressure vessel codes, section 2 and section 8 division 1. I hope you enjoy this presentation. So we're going to begin our outline with the North American material standards. I'm not an expert at European ones. I've seen them a little bit, but it's not my expertise. So we're going to focus on North American materials. Product types, talk about how the product types are important in material selection and how they relate to ASTM and ASME. Then we'll talk about the boiler pressure code, section 8 division 1. There are several design ASME section codes out there, but we're going to talk about section 8 division 1 and give you some ideas there. Now we'll also look at section 2 material requirements, and we'll look at that wonderful resource that ASME has called section 2, and we'll finalize that with an example. Unified numbering system, UNS for short, was a system that was developed based upon ASTM E527 and SAE J1086, and it was developed about 50 years ago, 50 years plus, back in 1972. And basically, UNS allows a correlation of many nationally recognized numbering systems by societies, trades, and trade organization producers of metals to avoid confusions, because there were so many materials that they were starting to get confused about things. But you need to know that this is only based upon specified chemical composition. It is not a material spec, but it allows for cross-referencing. So you still need to go to ASTM and those other codes to find out about the specific materials. This was quite an undertaking, and all the industries basically got together. In particular, the Copper Development Association, where was big players. Of course, ASTM International, ASME, the American Society of Mechanical Engineers, SAE International, and an organization which I belonged to many years ago, the Steel Founders Society of America, and the American Iron and Steel Institute, and the Aluminum Association. I know I've missed others, but these are the big players, and there are more. Textbook, and the textbook that I used in university, they went a great deal through UNS, and basically it's just an indexing system. They've allowed specific characters to go with each one. So you can see at the top here you've got, for example, the A's for aluminum, which makes sense, and then wherever they could make sense of it, they did. So you have A for aluminum, you've got cast irons, F, and N is one of the big ones. This is the the nickel-based alloys, like alloy 625, for example, is a very common, material used for, corrosion resistance. And you can see the list. And it's quite universal, but there's always exceptions to this where they have. But this is the broad classification. We're going to bore down into the American Society of Mechanical Engineering and look at how they work with UNS and how we pick materials for pressure vessels. ASME is a very old standard. It's been around a long time, and when you look at it, you can see it feels like it's been added to in layers, and that's because it has. So when you look at materials, for example, you can see UG is for materials, product requirements, and then down below you've got the the material UCS, which is carbon steel, NF, non-ferrous materials, HA, high alloy. So, and HT with, heat treatment influenced materials, and UF for forging. So you can see how they've tried to make everything, logical, and they have a sort of a hierarchy. So the general product requirements, which are universal, and then the specific one for the materials. Now there's a few other sections: brazed materials, UB, and UCI, cast irons, and one that I'm quite familiar with is UCL, which is the cladded pressure vessels, and then there's the cast iron, and then there's the impregnated graphite materials. Basically a roadmap of the table. You can see how important it is by product type where to go in the specification, the ASME tables. And so basically you've got plate, forgings, castings, tubings, and miscellaneous materials, and so on. And so the general requirements we talked about, so if you want general requirements for plate, you would go to UG5. For low and carbide, low and low alloy carbon steel, UCS6. Non-ferrous materials, you'd go to UNF6, and you can see the different product classes, that you can use. Welding materials would not be in this presentation, but if there's a request, we can talk about that. But in particular, if we go to Section 8, Division 1, you would go to UG6 and ASME Section 9 for that information. Section 2. Section 2 is pretty interesting. So you have a part A, which is ferrous materials like your irons and your steels, and then you've got your non-ferrous alloys like your Inconels would be part B. And what you'll see is that these are the listed materials, and they borrow pretty much everything from ASTM, and so basically, for example, you have 516 grade 516 plate, A516 plate. The ones that are appropriate for use for pressure vessel have to meet the SA516 requirements. So a pressure vessel person can go ahead or a fabricator can, with an ASME certificate, can upgrade by A516 plate and upgrade it by inspection of their choice, and they can do the inspection, and then it becomes an SA516 grade 70 plate. So basically, that's the difference. I mean, when you read them, part A and B, those specific specifications are almost identical to the ASTM. There are differences, and you have to be careful. And also, like part C has to do with welding electrodes and filler metals, and that would be another presentation to talk about, but that's all related to Section 9. And in particular, today we're going to talk about part D. We're into ASME Section 2. Table 1A is ferrous materials, and this is we're referring to the part D here. And so basically you have to be careful about which code you're using. So there are tables specific to, say, sections 1, 3, class 2 and 3, and section 8, division 1, which is the one we're going to be looking at today, and section 12. So but there are other tables, and the same thing with the non-ferrous materials. Now this is a really interesting spec because it has all kinds of information about creep and so on, and stress intensities, and there's a great deal of information, and it references other construction codes, and it provides a lot of physical properties like thermoconductivity, and basically the industry and all the software that you'd use for stress calculations references this table. It has the credibility. So in reality, you shouldn't be using a textbook. You need to use these tables because they're the most accepted. Now you can see from table 1A how you can use get your UNS number, and then you can get your pipe materials that you need, and then get your pipe specs. And then from there, you can determine your allowable stresses based upon the code that you're going to design to. In our case, we're designing to Section 8, Division 1. For example, we're going to take an example of a metallurgist has selected Sandvik 254 SMO, and we're going to replace a materials in a vessel. We're going to do a material upgrade. The thickness I've determined to be 3/8 of an inch because I've done the calculations, for example. So let's not worry about that. When we go to Section 8 Division, Section 2, the thickness will matter in some cases of the mechanical properties. So it's important to make sure you know your thickness before you start. And so then you need, basically this material is a high alloy austenitic stainless steel for very aggressive chloride environments. And you can see from the vendor has gone ahead and they said that they use UNS S312 254. So there's our hints there where we can start our work. We have our vessel, and we have to identify our product codes, and we call that table I gave you earlier. So in some cases, our nozzle might be a fairly large nozzle. We might use a pipe, for example, and in other cases we'll use plate for sections like shown here, and for small nozzles we might use a forging, and for flanges we'd use forgings. And then plate, we might use a roll plate for a very large nozzle. And now, at the end of the day, it's up to the pressure vessel fabricator to really choose what they want to do, because they need to get the lowest cost design, which works for their particular facility. Bear in mind also that supports are not applicable to the pressure vessel code. So let's go and we're gonna take one of these items shown here, and we're gonna go through it and look at the code as we wrap up our example. So we're gonna go to table 1A, and we have our UNS number from before, and we're looking for a forging. So now all of a sudden we've got our spec. We're supposed to use SA 182 grade F44. And here's some information over here that you should be aware of. P, and that will assist us in further work doing things like materials welding selection and matching up different materials and so on. So then we continue down our list and we look at our material grades. So remember, we have different codes: Section 1, 3, Class 2 and 3. We got Section 8, Division 1 and 9. And so then we have forgings, which is F44, and you can see that we've matched up our UNS code. So, but there's some more interesting things we need to look at here. So you can see that we have two lines here, 44 and 45. So which one do we use? That would be a question that comes in your head. Well, this comes down to what code we are using. So for this particular material, we cannot, NP means not permitted. So this material, if we're following line 45, we can't use it for Section 1 or 3 designs. It's just not permitted. Let's find something else. But for Section 8, Division 1, we can, 44, 45 is applicable, okay? But in this particular example, this really has to do with if we're designing to Section 3. So you can only design with this material if you meet the requirements of G5. Otherwise, G5 is not applicable. Okay, so that's basically how it works, and so we can continue with that. I can show you the actual notes if you're curious. These materials have to do. These notes have to do with the allowable stresses in the parts that the designer would see, and if the stresses are highly stressed, for example, if you read these details here, then then you have to be aware of that in your design and avoid those situations in order for you to use Section 3. But in our case, we don't need to worry about that note. I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.